Today we're going to finish up section 4. Yesterday was just part 1. Today is part 2. We're going to be talking about lines of fit of scatter plots. When data show a positive or negative correlation, you can model the trend in the data using a line of fit. A line of fit is a line drawn on a scatter plot that is close to most of the data points. So remember yesterday, to tell if something had positive or negative correlation, it had to look like the points were kind of clustered around a line, right? That line that we were talking about yesterday is the line of fit. If our points are clustered around a line, we can draw a line of fit through it. It's got positive or negative correlation. If my points are so scattered out that I can't tell what kind of correlation it is, do you think I'm able to draw a line of fit? No, because I can't tell what's going on with that data. Okay, does everyone understand what a line of fit is? It's a line that best closely represents our data. Okay? Can I move on, or is anyone writing this down? I'll take that as I can move on, since no one answered me. Do what? Yeah, so you're writing? Yeah, I'll give you time. No one answered me. Everyone good? I would write these steps down. These are the steps we're going to take to create our line of fit and write an equation of our line of fit. So step 1, we first want to make our scatter plot of the data if it's not already created for us. Making a scatter plot's pretty easy as long as you know how to graph ordered pairs. That's all it's doing. Graphing all the ordered pairs that they give you, that creates your scatter plot. Everyone knows how to graph ordered pairs? X comma Y. X is our horizontal movement, so we go left or right first, depending on if it's positive or negative. And then our Y value is our vertical movement. We go up or down, whether it's positive or negative. So right or left first, and then up or down. Step 2, decide whether the data can be modeled by a line. How do I know if it can be modeled by a line?
If it's positive or negative.
Positive or negative? Correlation, right? If it's got positive or negative correlation, then it can be modeled by a line because those points are kind of clustered around where a line might be. If we get no correlation, then I'm done after step 2, because if there's no correlation, I cannot create a line of fit. Step 3, draw a line that appears to fit the data closely. There should be approximately as many points above the line as below it. So, when we're doing our assignment, our answers might be a little different from each other, and that's okay, because you're drawing your own line through the data. Are all of our lines going to be exactly the same? No. So your equations will look a little different. That's okay, though. They should be somewhat close to each other, though. Like it says, there should be approximately as many points above your line as there are below. Okay? Step 4, write an equation using 2 points on the line. The points do not have to represent actual data pairs, but they must lie on the line of fit. Step 4 is just like what we've been doing in 4.1 through 4.3. Get 2 points, create an equation of a line. Okay? Also on step 2, you won't see any of this today, but sometimes our data can represent other types of functions. We're just going to deal with linear models of our data sets. Okay? So, positive or negative correlation for us, it can be modeled by a line. No correlation, it cannot be modeled by a line. Are there any questions about any of our steps here? Any questions? We still writing? Okay, I'll give you a little bit of time. Good? All right. So here's an example. It says the table shows the weekly sales of a DVD and the number of weeks since its release. Write an equation that models the DVD sales as a function of the number of weeks since its release. Interpret the slope and y-intercept of the line of fit. So my x values are the number of weeks since the DVD's release. The Y values are the sales in millions for that specific week. Okay? So, what does step 1 tell us to do? Make a scatter plot of the data. So, I've got to go and graph all my ordered pairs and make my scatter plot. Okay? So, I've got my graph right here. I had to change my Y-axis, change the values up, because it was too small originally for my data set. So, I went up by 2s instead of 1s. First ordered pair, 1, 19. So, I'm going to go right 1, up 19. Next ordered pair, 2, 15. Right 2, up 15. 3, 13. 4, 11, 5, 10. 6, 8, 7, 7. And 8, 5. Any questions on creating the scatter plot? We're all okay? Graphing ordered pairs like I said earlier. Okay, step 1's done. I've created my scatter plot. What does step 2 tell me? Decide whether the data can be modeled by a line. So I've got to see what type of correlation we have here. What type of correlation would we have here?
Negative.
Negative, so do you think it can be modeled by a line? Yeah. Because it has positive or negative correlation. If it had no correlation, I wouldn't be able to model it with a line. So step 2, check. Step 3, draw a line that appears to fit the data closely. There should be approximately as many points above the line as below it. Once again, this is where our answers are going to vary a little bit. So let's draw our line real quick. Try to make it go right through the middle of our data. Have as many points above our line as below it. Does that look pretty close to going through the middle of our data? Yeah. Looks like I've got about 1, 2, 3 points above my line. 1, 2, 3 points below my line. And actually 2 of them ended up being on my line. Right? So that's pretty accurate line of fit for our data because it just goes right through the middle of all our data points. Everyone okay with that? Step 3 is done. Step 4, write an equation using 2 points on the line. The points do not have to represent actual data pairs, but they must lie on the line of fit. Can my points be actual data pairs? Yeah. If they're on my line, we could use those points. So, does anyone see 2 points they would want to use to create our equation of our line?
5 and 10.
5, 10. That'd be right here. That's one of our data points. It's okay to use. Anyone else see another one we'd want to use?
6, 8.
6, 8, yeah. Another one of our data pairs also fell on our line. So we can for sure use those 2 points. From here, like I said, it's just like 4-1 through 4-3 that we dealt with before the break and since we've been back from the break. I'm going to use those 2 points to create an equation. Okay? So what do you guys want to do first here?
5, 10.
What about 5, 10?
Oh, what are we doing?
We got to create an equation.
The triangle thing?
What do you mean the triangle thing?
Let's do the
Rise
rise.
over run?
Rise over run. We need our what?
Rise.
Slope. We need our slope. We can use rise over run. We can use our slope formula. Either of the two will give us our slope. So rise over run here. If we're going to use these 2 points, what's the height of the triangle?
1.
And don't say 1. Is my y-axis going up by ones?
No.
It's going up by
2.
twos. So what's the height of this triangle? 2, because it goes from 8 to 10, right? So it's 2. Over, what's the width of the triangle? 2. Are my x values going up by 2s? 1. Gotta pay attention there. And then what does slope do say on that line going downhill from left to right? Nice negative. So my slope is negative 2 over 1, or just negative 2. Everyone okay with how I got the slope? We also could have done y2 minus y1 over x2 minus x1. We get the same thing. Questions there? Okay, now what? Where do you guys want to go from there?
Y.
What about y?
The slope something.
Point slope form?
Yeah, that
Yeah, we can plug in point slope form. Which point do you want to use?
5.
510. Okay. Y minus y1 equals m times x minus x1. We're using 5, 10 in our slope of negative 2. So can someone raise your hand and read off the equation for me? The whole thing.
Okay. Y minus 10 equals negative 2. X minus 5.
Very good. Plug in your y value from your ordered pair for y1. Plug in your slope for m. The x value from your ordered pair for x1. We are going to want it in slope-intercept form. So now I've got to convert it. So let's distribute.
Negative 2x.
Negative 2x.
Positive 10.
Positive 10 when I distribute. Very good. My last step to get y by itself.
Add 10.
Add 10 to both sides. So I get y equals
Negative 2x plus 1.
negative 2x plus 10. Very good. So there's my equation. Y equals negative 2x plus 10. Any questions on how we got that? So, first part of it is done. Write an equation that models the DVD sales as a function of the number of weeks since its release. Check. Have we interpreted the slope and y-intercept of the line of fit yet? No, we have not. What is my slope?
Negative 2.
Negative 2. What is my y-intercept?
10.
10. So, based on our situation here, we need to interpret our slope and y-intercept. Slope is negative 2 over 1. Remember, slope is change in y over change in x. What are our y values representing? Sales in millions. What are our x values representing? Number of weeks since the DVD's release. Right? So for our slope, it's the change in y over the change in x. Negative 2 over positive 1. So can someone raise your hand and explain to me what that would mean in this scenario? How would we interpret that?
Wouldn't that be for every 2 weeks? That they get 1 TV somehow? Sorry.
You're close. Remember, change in y, what did the y values represent?
Weeks. Oh no, really? Oh.
Sales of millions, right? So what do you think negative 2 means in that case?
Every time they lose $2 million,
Say that again.
every single time they lose about $2 million, I'm not sure.
Kind of.
I mean, it's negative, so.
Right, it's negative, so something's going down, right? And then per 1 week, right? So we could say something along the lines of the sales decreased by approximately $2 million per week. And that'd be me interpreting the slope. Does that make sense? Because remember, change in y values are representing my sales of millions. So the sales are decreasing by $2 million per 1 week after the DVD has been released. That's what I would put on my paper. Does that make sense? Okay, now we need to interpret the y-intercept. The y-intercept is what? The y-intercept is what? 10. So that'd be an ordered pair of 0, 10, right? So what do you think my y-intercept means in this situation? Zero, 10. X value 0. Y value is 10. X represents weeks after the DVD has been sold or been released. Y represents sales in millions.
Sales gain.
Say it again.
Sales gain.
Not quite. We're not doing a change in Y over change in X anymore. It's just an ordered pair. 0, 10. Remember, X value represents weeks since the DVD's been released. So how many weeks has it been since the DVD was released? 0. It just came out. Right? What does Y represent? Sales of millions. So how many millions of sales did they have when the DVD first came out? $10 million. Right? So that's what I would say in my paper. When the DVD first came out, they had $10 million worth of sales. Something along those lines. Does that make sense? Think about X and Y and where the X value is, where the Y value is, and interpret it based on the situation. Okay? Have we answered everything on example 3 here? Yeah, we gave the equation, we interpreted the slope and the y-intercept. Any questions for me on that?
I was going to ask for when you did the point slope form
Yeah.
equation, what if you used the 6 and 8 one?
You can use the 6 and 8, you'll get the same answer. Yeah, it doesn't matter which point you use. Okay? We would get y minus 8 equals negative 2 times x minus 6. If I distribute that, get negative 2x plus 12. Add 8 to both sides. I'd get y equals negative 2x plus 20 as well. You get the same thing. Okay? Any questions? Other questions? Here's your assignment. Page 204. 13 through 18 all. It's 6 problems. Due Thursday the 12th on Canvas. Make sure you get the correct heading on your paper. Name, date, period, assignment. Remember, for the date, it is the year 2023. Do we have any questions about the notes before I end the recording? All right.